more innovation, and more prosperity. What we've achieved so far is beyond belief, but this is truly just the beginning of a bigger, more exciting journey. Ocean is the starting point of all possibilities. It's where we came from. It's where we are heading for. In the ocean of data, we leverage the power of convergence to unleash the potential in explosive data. Facing complexity, we adapt with stability. We make data storage clean, sustainable, and reliable. Facing changes, we adjust with agility. We enable efficient and on-demand data storage management. Facing bottlenecks, we create unlimited potential. We build new types of storage to help discover miracle of lives. Facing opportunities, we thrive ecologies. We respond to future business surge with innovative technologies. We choose for never-ending exploration. Green. Accelerate. Innovate. Let's embrace a green and digital future. Huawei Ocean Store Data Storage. Convergence of all possibilities.
Recorded information is essentially the story of civilization. At every turn, new storage methods have led to new human progress. From using the natural world to processed materials, humans have recorded, stored, and passed on information through increasingly accessible ways. As the transmission of information is advancing rapidly, we aim to create the new media paradigm to make infinite storage a reality. From complex storage to concise solutions, storing ever-changing data is as easy as zeros and ones. From diverse storage to converged solutions, Next-Gen Media is driving the optimal solution for every situation. From transformative storage to disruptive solutions, trillions of bytes can be processed in a flash. Cutting-edge technology helps us keep pace in our digital world, hosting and sharing information with unlimited capacity. Driven by storage innovation, let's explore the future of new digital models, momentum, and business forms, and usher in a better economic society for all. Let's unleash the full potential of data and shape the future of industries. Starting from the binary number 1, we have created billions of bits of data that is powering the world. Coding has opened up a whole new world. In the large AI model era, a sea of data is shaping and fueling industries and redefining our roles in the world. Intelligent programming goes beyond traditional coding. It unleashes creativity and breaks down complex problems into simple code. The boundary between the physical and virtual worlds is becoming increasingly blurred, the ability to capture the finest of details in stunning ultra-high definition, is revolutionizing the film and television industry. The genetic code has been converted into data, and we can use it as both a sword and a shield against disease. China's 7-minute genome sequencing process marks the start of a new chapter in medical treatments. Data is the cornerstone of the large AI model era. The next-gen AI beings in this era will help us adapt to changes in a wider range of scenarios. Data determines how successful AI will be. Huawei Storage takes a data-centric approach and is working to help reshape industries.
A new era is often unlocked by a critical breakthrough. Steam engines pushed the frontiers of power. Electricity illuminated our lives and boosted productivity. Information technology changed the way we live and create. Every breakthrough in technology changes the world around us. How much we do today will decide how far we can go tomorrow. From a seed of discovery to rapid progress, today, digital and intelligent technologies are unleashing unprecedented power. By building digital, intelligent infrastructure, we can help all industries boost productivity, defy limits, and move full speed ahead. By diving deep into practical challenges, we can tailor technology for any scenario, unleashing innovation for untold value. By building digital, intelligent ecosystems, we can foster more talent, more innovation, and more prosperity. What we've achieved so far is beyond belief, but this is truly just the beginning of a bigger, more exciting journey. Ocean is the starting point of all possibilities. It's where we came from. It's where we are heading for. In the ocean of data, we leverage the power of convergence to unleash the potential in explosive data. Facing complexity, we adapt with stability to make data storage clean, sustainable, and reliable. Facing changes, we adjust with agility. We enable efficient and on-demand data storage management. Facing bottlenecks, we create unlimited potential. We build new types of storage to help discover miracle of lives. Facing opportunities, we thrive ecologies. We respond to future business surge with innovative technologies. We choose for never-ending exploration. Green. Accelerate. Innovate. Let's embrace a green and digital future. Huawei Ocean Store Data Storage. Convergence of all possibilities.
Recorded information is essentially the story of civilization. At every turn, new storage methods have led to new human progress. From From using the natural world to processed materials, humans have recorded, stored, and passed on information through increasingly accessible ways. As the transmission of information is advancing rapidly, we aim to create the new media paradigm to make infinite storage a reality. From complex storage to concise solutions, storing ever-changing data is as easy as zeros and ones. From diverse storage to converged solutions, next-gen media is driving the optimal solution for every situation. From transformative storage to disruptive solutions, trillions of bytes can be processed in a flash. Cutting-edge technology helps us keep pace in our digital world, hosting and sharing information with unlimited capacity. Driven by storage innovation, let's explore the future of new digital models, momentum, and business forms, and usher in a better economic society for all. Let's unleash the full potential of data and shape the future of industries. Starting from the binary number 1, we have created billions of bits of data that is powering the world. Coding has opened up a whole new world. In the large AI model era, a sea of data is shaping and fueling industries and redefining our roles in the world. Intelligent programming goes beyond traditional coding. It unleashes creativity and breaks down complex problems into simple code. The boundary between the physical and virtual worlds is becoming increasingly blurred. The ability to capture the finest of details in stunning ultra-high definition is revolutionizing the film and television industry. The genetic code has been converted into data, and we can use it as both a sword and a shield against disease. China's 7-minute genome sequencing process marks the start of a new chapter in medical treatments. Data is the cornerstone of the large AI model era. The next-gen AI beings in this era will help us adapt to changes in a wider range of scenarios. Data determines how successful AI will be. Huawei Storage takes a data-centric approach and is working to help reshape industries.
A new era is often unlocked by a critical breakthrough. Steam engines pushed the frontiers of power. Electricity illuminated our lives and boosted productivity. Information technology changed the way we live and create. Every breakthrough in technology changes the world around us. How much we do today will decide how far we can go tomorrow. From a seed of discovery to rapid progress, today, digital and intelligent technologies are unleashing unprecedented power. By building digital, intelligent infrastructure, we can help all industries boost productivity, defy limits, and move full speed ahead. By diving deep into practical challenges, we can tailor technology for any scenario. Unleashing innovation for untold value. By building digital, intelligent ecosystems, we can foster more talent, more innovation, and more prosperity. What we've achieved so far is beyond belief. But this is truly just the beginning of a bigger, more exciting journey. Ocean is the starting point of all possibilities. It's where we came from. It's where we are heading for. In the ocean of data, we leverage the power of convergence to unleash the potential in explosive data. Facing complexity, we adapt with stability. We make data storage clean, sustainable, and reliable. Facing changes, we adjust with agility. We enable efficient and on-demand data storage management. Facing bottlenecks, we create unlimited potential. We build new types of storage to help discover miracle of lives. Facing opportunities, we thrive ecologies. We respond to future business surge with innovative technologies. We choose for never-ending exploration. Green. Accelerate. Innovate. Let's embrace a green and digital future. Huawei Ocean Store Data Storage. Convergence of all possibilities.
Recorded information is essentially the story of civilization. At every turn, new storage methods have led to new human progress. From using the natural world to processed materials, humans have recorded, stored, and passed on information through increasingly accessible ways. As the transmission of information is advancing rapidly, we aim to create the new media paradigm to make infinite storage a reality. From complex storage to
Ladies and gentlemen, the keynote speeches will begin in 1 minute. Please take your seats and ensure that your mobile phones and other electronic devices are muted. Thank you.
With every passing moment, zeros and ones change all the time. convergence, acceleration, intelligence at your fingertips. Chart civil wars on an intelligent foundation. Strive for breakthroughs, enabling digital pathology systems. Explore new ecosystems for intelligent manufacturing. We shape our reality, stretching the bounds of technology beyond imagination. Awakening an ocean of data, we spark the evolution of large AI models. The universe unfolds through countless moments of zeros and ones. In our pursuit of faster and more resilient storage solutions, we will redefine humanity's journey ahead. Awaken your data now as AI rises.
Distinguished guests, ladies and gentlemen, good morning and welcome to the Huawei Innovative Data Infrastructure Forum 2025. AI accelerates data awakening, and we're now entering the golden age of data. Indeed, data is the core production factor of the intelligent economy, and the scale, quality, and processing efficiency of data are key to boosting enterprise efficiency. And as the carrier of enterprise data assets, data storage has become a strategic infrastructure for accelerating the development of the digital economy. Huawei is committed to developing AI-ready data storage, enabling AI large model training and inference, and accelerating the implementation of AI industry-based applications. Huawei is also focused on helping customers from all industries aggregate valuable data, improve data processing efficiency, ensure data resilience, unleash data value, and ultimately move towards an intelligent world. Today, we come together with thought leaders, business leaders, technical experts, and partners from all over the world to discuss how to build a future-oriented, innovative data infrastructure so we can thrive in the intelligent era. Now let's kick off with an opening speech. Please welcome to the stage President of Huawei European Enterprise Business, Mr. Willy Song.
So, ladies and gentlemen, welcome to this year's Huawei IDI Forum. We are glad to host this event for the fourth time. I want to thank our customers and partners for your support, and I'd like to extend a warm welcome to all of our guests. So over the next 10 years, intelligent transformation is a huge opportunity for Europe. On April 9th, the European Commission introduced the AI Continent Action Plan, which aims to position Europe as a leader in AI. This plan outlines several key actions, like setting up 5 AI gigafactories and 13 AI factories in Europe. It also emphasizes the need to create large-scale, high-quality data through data labs, while speeding up AI adoption and developing AI talent. So Huawei will keep working with our European customers and partners to drive intelligent transformation across industries. And our efforts will be supported by our all-intelligent strategy. So advanced information and communication technology, along with 29 R&D centers and 2 open labs across Europe. So plus, we will continue our partnership with over 210 European universities to develop more ICT talent. So far, Huawei Data Storage has served over 26,000 customers in more than 150 countries and regions, protecting a massive 30,000 petabytes of data. Notably, 53 of the world's top 100 banks have partnered with us. That really shows the trust they have in us. So looking ahead, we will keep promoting the strategy of going all-flash and use advanced semiconductor SSDs to build data centers. So our Ocean Store Dorado all-flash storage provides outstanding performance and reliability for mission-critical applications. With this solution, Huawei has been named a Partner Peer Insights Customer's Choice for 4th time. We truly believe that the science has no borders, and data is its lifeblood. So our Ocean Store Pacific Scale-Out Storage creates unified and shared data lakes to support education and scientific research. This product has helped a leading educational institution in Europe build a large-scale platform for research data management. As a result, all member institutions can equally share their research resources. We also focus on supporting Europe's aim to go green when it comes to data protection. Our Ocean Protect backup storage use innovative data reduction algorithms to store 40% more data in the same amount of space. This solution has helped a European healthcare customer improve their backup reduction ratio by 140%, which has greatly reduced their physical footprint and energy consumption. So Europe is one of Huawei's most important markets. We will stay true to our in Europe, for Europe strategy and strengthen our collaboration with all sections in this region. At this year's forum, we will look into industry trends, launch new products and solutions, and hear valuable insights from our customers. I wish the forum a great success, and once again, warmly welcome to all of you. Thank you very much. Thank you.
Thank you, Mr. Willie Song, for your inspiring speech. With the rapid development of large models, AI has gone from a wide range of chat applications to specific industry scenario-based applications. So which industries are taking the lead in using AI? And how can enterprises successfully navigate the intelligent era? The next speech will offer some insight into this. Please welcome to the stage General Manager and Group Vice President and IDC Research EMEA, Mr. Thomas Meyer.
Good morning. Welcome, Mr. Song. Thank you very much for your introductory speech. And thank you for getting us all here together in this room, because as technology leaders, as business leaders, this is the opportunity together to move ahead in this format as a community and hopefully get together, innovate, and figure out how we together can drive success by navigating the intelligent era. Welcome, everyone, from my side as well. I haven't had far to go, only 40 minutes for me. It's great to have this wonderful weather here, and hopefully just a tremendous time today connecting and finding out more about what technology has in store for us and what innovations lie ahead to help us succeed. I'd like to do a couple of things today, show you from the conversations that we've had with CIOs and CTOs and CDOs, where we think the industry is at the moment, and hopefully you'll get a sense of where your organization, your business is at this point, but also hone in on one of the major barriers that we see in the industry at the moment in terms of moving ahead towards an intelligent era and really embrace AI. So, without further ado, what we've done is look at sort of some of the imperatives that exist as you move through your journey as an organization. And there are three elements around the business, and then we have the technology elements. So think about the business in terms of strategy, people, and governance, and then you also have the tech stack. And obviously, I'll come back to that in a second. Now, as you move ahead from what I think is fair to say has been a scramble, we're now entering the pivot time. That means it's becoming more coordinated before we then move very swiftly towards the AI-fueled era, where AI is integrated in everything we do. And you've heard agentic AI named a few times, where we are in this era where workflows, processes, people are very heavily driven by and influenced by agentic AI. Now, you still need to get there in some way, shape, or form. So where are organizations at this point? And we did a significant survey, thousands of respondents, looking at strategy, people, and technology, and said, where do you think you are? So this is a self-evaluation, saying, like, on this wonderful journey, have you moved from the scramble? Are you becoming a little bit more opportunistic already? So you pick up those opportunities that exist. Are you maybe a little bit more already aligned around AI? And I think it comes as no surprise when we look at this, that organizations are still in the starting blocks, but they are beginning to move to the AI pivot. So when you think about where your organization is and how you can compete, successfully compete in the new era, then that is now the time to act and move. Now, that said, it's not easy. Most organizations start at the point where they go, okay, by function, which use cases are important to me? And I'm sure, maybe I'll ask the question, does anyone not have any AI of any sort in their organization? No co-pilots, no chatbots, no anything? Interestingly enough, we had a recent survey and there were about 2% of organizations that haven't looked at this. But most organizations are on that journey. So if you pick one, and I've picked a very popular one, contact center. So if you look at customer service, contact center, and then you think about, okay, so what are sort of like the key use cases that exist there? Then you very quickly come to, well, it's great to get real-time summarization. It's great to get multilingual support. So we can make these things more automated, quicker. We can increase the customer happiness. And obviously, we can increase the level of productivity in organizations. Now, before I sort of talk a little bit more about where organizations are, let's just look at industries. So remember that benchmark, most organizations are sort of stage 2, stage 3. If we're looking at it by industry, we've seen particular media embrace the new era of AI very quickly. The same for tech companies, telco, but also finance, which is interesting, but also not unusual. Finance has been at the forefront of technology for many years. because there is a clear advantage when looking at finance. So when we look at each of the individual industries, and we've got this for multiples, we look at what are the survivors in that industry doing, what are the thrivers doing, what are the ones that are moving ahead really quickly, what are those organizations doing? And they invest early, they look at chatbots, and they have done this for a long time. They also look at fraud, and ideally trying to prevent fraud. They're looking at governance very clearly. I talked to one head of security for one of the big banks, and she said she has to manage 38,000 control points. Now, with people, that's really tough. In an automated fashion, and they've got their own AI team, they can do this. So think about what moves the needle in your organization, because here's the other side. On average, organizations run around 40 proof of concepts. Those proof of concepts, out of those, about 5 are put into production. 2 are successful. So we're right at the beginning of this journey, but the time to pivot is now. Because when you think about it, when you compare yourself in terms of what's happening in your organization, in your industry, if you go and do the business as usual thing, that's probably reasonably successful. We've learned a lot around supply chain management during COVID times. We suddenly realized I might need real-time data. I might need to do forecasts once a week, once a day, not every month, not every 6 months. So when you look at your industry and you look at your competition, you look at where you want to go and want to be successful, be careful to avoid the innovation gap and start honing in on what you need to succeed in. Now, it's clear this is a big organizational change management exercise, but there's also a big tech stack that needs to be in place in order to support this. Now, people and scaling with people and convincing people that AI is a good thing and working with AI is great is one side. But when you bring it down in terms of what drives things forward and what holds things back, infrastructure is a big element, top element, in terms of moving AI along more quickly. So the disruptive impact of AI is tremendous. I guess that's a no secret. Throughout all levels that we've described here in terms of the technology stack. Now, it's no secret either that when we think about the complexities, what data is valuable, where's my data, is it in the right format, how do I build potentially big, scalable areas of data lakes. Mr. Song talked about this already as well. We'll hear a lot more about this today and in the showcase as well from Huawei about the technologies that are important because data is the fuel for your organization going forward. You've got to think about where the data is, what governance you need, how to secure it, how to scale it, all those wonderful things. Because when we move forward, it's quite clear data is just going to explode. And no matter what happens in the economy, that will happen in all regions of the world. It's going to be a humongous amount of data. And for those of you who, like me, have been in the industry for 25 odd years, you would have heard the story probably every year. But this is now the point in time when, if you think about a car journey and the data it generates, if you think about financial transactions and the data it generates, if you think about healthcare and the possibilities that exist by using data to drive things forward, if you think about many organizations here in Germany as well that work in medical technology, medical devices, that create data, where technology is the business now, then this is absolutely key. Now, when we look at the successful organizations that are doing well in terms of Gen AI specifically here, and we look at what they need, there is a correlation of the data element, the infrastructure element, storage element, and the success that digital leaders are facing and experiencing. So I would encourage you to look at that and think about, we've got lots of detail for each of these stacks, but think about, just at this top level now, what's important to you, what do you need to tackle? From our survey, again, just very recently, you need to take some money in hand. And I know this is a tough conversation, because no matter how much the CEO word of the year, by the way, for 2025 is innovation, it was growth for the last 2 years. No matter how much the CEO wants to innovate, he's also likely telling the IT department, and can it please not be very expensive? So there's this balancing act that needs to be done again between innovation and cost. And I think that's just a reality. But there needs to be money made available to remain competitive and stay ahead. And that goes to data center infrastructure, cyber recovery and resilience, but also the enterprise apps. Now, that's a tough one to manage. It's all very easy on PowerPoint slides, I admit that. But hopefully it'll give you some flavor of where we are in terms of the industry and where we see the industry from the conversations we've had as well. And I'd like to leave you with two thoughts before I go. The one thing is, if you're looking at it more strategically, think about it this way. There are probably 3 things that you really need to focus on. One is the strategy. Have you got a strategy that's already aligned in terms of the investments and the roadmaps? Do you have priorities for the core business apps and processes that you actually want to automate, where you get the biggest return on your investment? And by the way, I think this is the thing about the proof of concepts turning into production and the low success rate. The conversations that I'm certainly having with CIOs across the globe at the moment are very much about the value that's being created or not being created, and rethinking how we need to think of the value that AI is generating. Think about what you need to do in terms of change management to take your workforce along. Because this scares a lot of people, but it's also a super opportunity in many other respects to move upwards and ahead. And then think of the tech stack. Where do you need to really focus on automation going forward? What kind of data sources do you have? Can you identify those as well? And then make sure that you invest in infrastructure and the automation, because eventually you'll be moving to a level of platform, but that's a longer journey going ahead. So as a last word, perhaps, if we look ahead to 2030, we're estimating that for every dollar spent on AI services and tools, just below $5 are getting generated in the industry overall. So that means that we see about 22.3 trillion in value being generated between now and 2030 in terms of AI. But if you want to serve your customers in new ways, if you think, and this is very likely, that your business is being disrupted by what's going on at the moment in terms of the AI era, think about what new industry value you need to be able to create, and also think about how this is impacting your operating model. But at the core of it, I think many of us want to fly before we can crawl, walk, and run. But the fact remains that to be successful in the intelligent era, you need to get the foundations right for AI-ready infrastructure and data. Without data, it's going to be very tough, and there is not much of a shortcut you can take going forward. Thank you very much for your attention. It was a great pleasure to be here today. I hope you have a wonderful time with your community, with Huawei, and obviously in the showcase as well. And hopefully, if you want to have a conversation with me, I'm around all day, happy to chat. Thank you so much.
Thank you, Thomas, for your fascinating presentation. So as we learned from Thomas's speech, the first industries to implement commercial applications of AI will be those with a large amount of high-quality data. He also provided some valuable advice on enterprise AI data infrastructure construction. Now we need to think about what to do and what good solutions or products can help us to do it. For this, let's invite Dr. Peter Zhou, President of Huawei Data Storage Product Line, to give the speech, Data Awakening, Accelerating Intelligence with AI-Ready Data Infrastructure.
Good morning, everyone. Really good to see you again this year in Munich. We all understand the digital transformation has been doing for quite a long time. In past decades, many things got changed. For example, infrastructure, application software, etc. Only one thing never got changed, which is the importance of the data. When we start to have database, we use data for recording. And then when we have big data, we start to dig into the data, try to have more information. And then when AI comes, data becomes knowledge. Therefore, for all the organizations, to make AI ready, I really believe we have to get data ready at first. And then to get data ready, we really recommend all the organizations to consider to build AI data lake. For AI data lake, we really believe there are several key elements. The first thing, certainly, is most important, is data storage. Within this kind of layer, we believe the high-performance data storage, which is really expensive, has to be together with high-capacity data storage, with cost-effective. And then, certainly, data protection storage, for example, backup storage, with effectiveness. These data storage has to be tiering together. And then, certainly, the data management is really important to make sure even the data located in different physical places, the owner can understand where is the data and what they are and how to use it. And certainly, we need to add on AI tooling chain, these kind of softwares, to help us connecting these data to the large modeling and also even connecting to the application softwares. And certainly, the management system also becomes more complicated. Therefore, we needed to have a clever way to manage all the hardware and also software together with the data assets. The first thing, as I mentioned, a very important thing, is data storage. And then what kind of data storage today Huawei started providing to our customers? The first thing is high-performance data storage. From last year, we are recommending to the market with OceanStor A-series products. This storage really got high performance for NAS particularly, and with really high capability of scale out. The A-series data storage really got high bandwidth, therefore can enabling it to connecting to even more than 100,000 GPU cards because the large bandwidth. And also, it really got performance enabling for the training and also inferring system. In last year, I also joined the MLPerf, that kind of competition, and certainly it became #1 within all kind of data storage. By using this data storage, the checkpoint loading speed really can be fasted. And also inference performance and also the user experience can also really be improved as well. So we are really strong recommending our customer to consider A-series data storage for the production area, not only considering the reliability, but also really considering to protect your investment for the future. The second thing we have to think about, more and more data we have to accommodate. We really believe in the future the cold data will go. More and more cold data will become warm data because the AI system has to visit these kind of data. Then we really needed to find a clever way to accommodate all these data with cost-effective. Our answer is OceanStor Pacific series product. The OceanStor Pacific today got certified by Energy Start. It really got high density with 2 units to support 4 petabytes. And also, for each terabyte, the power consumption is only 0.25 watt, which is the lowest in this world. And certainly, it supports really large SSD disk together with the capability of strong compression and also energy saving as well. The third element for the data storage layer is data protection, which is backup system. We all understand the backup system in the history has been used for database and also virtualization, these kind of systems. When AI comes, it will really used for AI corpus and a vector database, these kind of data backupping and also protection. So for backup system, we really needed to consider the efficiency of the speed for backup and recovery, together with the software features to detect where is the ransomware attack. All of these features are supported by Huawei backup system. Today, it has been used for many companies and also in many areas to keep protecting their data assets. The second thing is data management, as I mentioned, for AI data lake. We all understand today we got problem to manage the data. Today, in each organization, the data may allocate in different departments and also physically in different areas. For the owner of the information creator or builder in the organization, they really cannot understand where is the data asset, how to use it. So in Huawei data management engine, we have very important functionality called Omni Dataverse. This software can help us to understand where is the data and how to use it, particularly to make sure all these data can support mobility. So make sure the data in one organization could have visible, manageable, and also being available is really important as a first step for us to build AI data lake. And certainly, when AI comes to build AI data lake, the complexity will be further increased. So the resource management becomes more important to make everything be efficient. You know, we have virtualization system called DCS, has been introduced from last year. Traditionally, it supports the virtualization for CPU very well. And from this year, the DCS will keep support the virtualization functionality for NPU and GPU. Today, in most of the AI cluster, GPU card has been allocated on one by one. We never divide the resources within the one GPU card. And then the DCS, we provided the virtualization functionality for GPU, really can help us to further utilize the GPU resources within one card. We have an example. In China, we utilized 16 NPU cards for one hospital. And then hundreds of the doctors started to use the functionality within that kind of small pool. How to realize that the DCS virtualization for NPU really make effects. And certainly, container technology also supported within this DCS. So we are strongly recommend all the organizations start to consider the virtualization functionality for GPU and NPU when you start to build AI data lake. To make sure the maintenance and also the planning job be simplified, AI technology also be introduced to data management system. The functionality we called Data Master. It's really co-pilot functionality for engineers. With this kind of tooling system, the engineers can easily do the maintenance and also planning job, and even can minimize the mistakes. Okay, let's have a video to see what kind of AI data lake we have, please. AI data lake, we are really strongly recommending to all the organizations to build. Today, we have powerful all-serial data storage together with the software to support data management, virtualization, and also resource management as well. We really have confidence to support all the organizations to build AI data lake. Remember, to make AI ready, get data ready at first. Thank you.
Thank you, Peter, for introducing the AI data lake solution. So Huawei keeps innovating to build leading data infrastructure solutions, helping enterprises in global regions make breakthroughs in data intelligence. And with the advent of AI, these solutions will continue to evolve. The AI data lake is one of the key innovations. It makes the training and inference of AI large models more efficient and enables AI corpus data to be stored more economically and reliably. It also allows enterprise data to be efficiently managed and circulated while greatly improving the utilization of AI clusters. And it's clear to see the immense value that it offers. And if you're interested in this or any other topic from today's keynote, please share on social media with the hashtag HWIDI. Next, let's listen to some innovative practices about AI-ready data infrastructure. With its high-quality data, the healthcare industry has taken the lead in the industrial application of AI. Now let's invite Mr. Florent Gentric, CTO of Hoster SAS, to share how they are developing their AI business and building AI data infrastructure.
Hello, I'm here with you today to talk about our AI hosting solutions and how Huawei helps us to build it. We, Hoster, are Franco-Swiss cloud service providers specialized in providing complete or hybrid hosted solutions. For over 20 years now, we have witnessed several evolutions of hosting service in Europe. Since the beginning of the internet era, we are providing solutions throughout such periods like e-commerce, blogs, and all web contents. And after that, IaaS solution inside virtualization from Zen to VMware's, and now Huawei DCS solution. Cloud services like PaaS, and now SaaS. In 2019, we became certified HDS in France, data hosting providers for health data, to meet obligation from ensuring securities and organization for this highly sensitive data. Hoster is a small team that grows with talent along its history to remain at the forefront of its field, capable of providing necessary edge technologies while maintaining agilities, efficiencies, and innovation solutions. The figure of adoptions in AI technology worldwide shows that our profession must change once again. Certain concepts regarding our added value must evolve, and we must be ahead of solutions to address the new challenges in the sectors. Rather than just being a solution integrator, we must first understand, dissect, and explain the reality of the technologies and anticipate the risk associated with it. We are fortunate to meet experts, users, and decision makers who are both enthusiastic and fearful of missing out. The number of projects is increasing. At all levels, we can have 1 or 2 AI subjects. Sorry. 1 or 2 AI subjects per week, ranging from very basic projects to much more complex ones. Here, we are a few client cases we are working on. In healthcare, mainly, we work on a consortium with partners to implement a platform for making specialized models available to offer AI services to practitioners. This includes diagnostic aids, medical imaging analysis, administrative assistance, and more. We also work on more traditional sectors such as marketing, customer support, content management, and much more. Those projects involving intelligent agents, either as chatbots or in-app process workflow using LLMs, computer visions, or predictive models. Yes, or PaaS solutions could be an answer on that. But we want to be able to respond with more innovative and simplified solution. Also, one important aspect of the majority of our client requests in France is data governance. So we need to address this as well. The challenge was to manage resources effectively, provide basic and complex services, but in the clear and unified manners. Here is our vision. AI Flow is a platform that can be deployed in public, dedicated, or hybrid modes. It supports multi-services from pure AI services, and classic services, application modules, and any other containerizable services. It offers also multi-instances for scalability and resilience. And it supports multi-AI models. By executing AI models in one or many GPUs, it's being compatible with the market standards such as TensorFlow or PyTorch. Additionally, we can also execute some other workloads like R in math analysis or Spark in data processing. How does AI Flow address a use case like we discussed earlier? Where I mentioned a case that we are addressing with our partners on specific need for digital patient records. French government had asked technological medical actors to work on proposal to offer powerful and functional AI tools to aid healthcare professionals daily. Our job was to provide a platform capable to address it. AI Flow emerged from these reflections, aiming to provide reliable, flexible, controlled, and high-performing platform to develop tools for such a project. Firstly, offering data scientists and research laboratory a complete machine learning services for their process and produce models using the ML Workbench module. Secondly, managing the publication of those models once they're produced. Important aspects are publication tools to catalog models and usages, code quality and security to guarantee the best trust levels for data, and model identification system to avoid model duplication and theft. This model then has offered as an application to healthcare professionals. We called it Inference App. Simple to use and executed only on the platform to always ensure the best level of confidentiality. Depending on each model usage, every right holders are remunerated. These architectures can be also duplicated and adjusted with features and additional removal necessary for all other use cases. Now, in other contexts, we have produced AI Flow open platform, usable by everyone with similar concept. We find ML Workbench and Inference App modules in a more open form, allow users to produce and execute their workloads simply, or use already published app like chatbot system, AI engine, API endpoints, and more. Additionally, we have the AI SaaS modules, which like OpenAI or Mistral AI, the API ports of them, also allow our clients to benefit from shared AI resources to access widely used open LLMs models at a competitive cost. AI Flow Open Platform is a great sandbox for all emerging and advanced AI projects. Multi-tenancy capable and dedicate resources based on usage to respond to all user cases across all sectors. Here is a brief use case of open platform and how efforts app are used in the concrete application project. In example, the goal is to allow AI to facilitate administrative personnel's work in managing justification sent to validate application files for an estate company just here. The client wants to ensure that user-provided documents meet expectation and are coherent. Inference app is used in two modules there. One to address the computer vision models to read and analyze the document in less than 10 seconds. And another for an augmented conversational agent to perform complex search in the document base. Now, administrative personnel has two new tools in their own application to assist them and simplify recurring tasks, prevent errors, accelerate file processing. In this case, the client chooses to host only AI workloads inside AI Flow. But Inference app is designed to encapsulate much more. Indeed, Inference app can be used with GPUs, but also with CPUs. We wanted a reliable, scalable, and high-performance platform. So we built AI Flow on top of Kubernetes on Huawei DCS solution. Indeed, the ability to manage resources, build and implementation models as desired, be open to all containerization technologies, along with Huawei tools for managing VMs and storage, allows us to choose Kubernetes as the evident choices. Based on our expertise to maintaining and managing those platforms, we naturally adopt it. Today's mature and reliable compatibility with NVIDIA and AMD GPUs in the containers universe allows us to focus on resource servicing and optimization, rather than deploying management tools and many SDK. The massive usage on containerization sectors in AI, from development to production being reality, we significantly reduce future resource integration constraints by choosing this kind of technology. Now, let's discuss the core of the platform, focusing on machine learning with ML Workbench. The main challenges here are about resources and are ephemeral resources despite the financial implication given the current GPUs and costs. However, technical choices are quite limited for now. On data sides, it's a very different story. Like Mr. Meyer said before, everyone knows that the data storage, processing, and growth are a real challenge here. After working with Huawei on our block storage solution and choose to continue our partnership with them on object storages, we have two types of needs: capacities and performance. I remember us here in 2023. We discovered the Pacific Range in IDI. And now, object storage services we have are based on this product line. 9922 for full flash and Rocky support for ensuring learning performance, multi-protocols, and multi-tenancies. And 9546 for provide identity for big data and all data lake services. Our two strengths in collaborating with Huawei lies on integrating Pacifics or Dorado into hosted services, offering the best on-demand storage technologies. With built-in multi-tenancies, crucial in healthcare, and proven reliability after years of usage, we have the ability to achieve great things on solid foundation. Telling about tomorrow, we have several use cases using RAG techniques with LLM to produce agents without retraining procedures. Currently, we use open source products that are functional, but not too much optimal for the large data sets. We aim to build a service in AI Flow to offer this at scale. For this purpose, we're considering the A800 product significant part of the solution. Additionally, we wish to innovate a unique approach to data disclosure within these agents, working on an exciting project on this area. Oster always insists on innovation. By choosing Huawei storage, which also insists on innovation, make us really confident for the future. Thank you, everybody, and thank you for Huawei to have us here presenting our ideas and expertise. Merci.
Thank you, Florent, for sharing your valuable experience. Another typical industry with high quality data is finance. Because financial services have such strict requirements on immediacy, stability, and resilience, the financial industry has taken a major lead in the digital era. Given this, what should the data infrastructure of the financial industry be prepared for in the AI era? Well, let's hear the answer from Germany's VHV Insurance Group. Let's welcome to the stage Mr. Fabian Degenhardt. He's Head of Digital Development Infrastructure Operations at VHV Group.
Hello everyone, nice being here at the Huawei IDI Forum. I'm Fabian Degenhardt, I'm the head of our infrastructure operations department, and I would like to tell you a little bit about how we at VHV Group are preparing our storage systems for the future. To give you a short introduction what we do, we are an insurance group from Germany with a really old history. We are over 100 years old. Some of our business units are even older than that. And last year we reached a milestone in our development. We generated over 4 billion of contribution volume, which is a really significant number for us. We have 3 core brands that we are operating with. If you are from Germany, you may know them. We have the VHV Versicherung, which is our car and building insurance company. We have the Hannoversche, which is our life insurance company. And just recently, we started the VHV International, where we are aiming to go more into Europe and where we are bundling our international subsidiaries. We are facing 3 main challenges in our IT department. And I took a long thought how to transit here. And let's talk about the mainframe for a second. Because we as an insurance company have been using IT longer than most tech companies exist. We started our mainframe more than 50 years ago. It's much older than me. And right now we are facing the challenge that we have a very complex IT infrastructure. We have these really, really old legacy systems. We have the a bit modern, more standardized client and server systems. And we are also operating cloud systems. All these 3 systems need to be managed in some way, and we need to handle this complexity. On top of that, we have quite a large number of highly specialized systems for claims management, for our capital management, and so on. And last but not least, a lot of these systems are intertwined. We have really high number of interfaces between these systems. So it is not easy to change one of it. The second challenge we are facing is adaptability. And this is really a main one. We need to be able to react quickly to customer demands. The business demands change more quickly. The business dictates the pace, and rightfully it does so, because IT as itself is not what we aim for. We are an insurance company, and our time to market needs to be low. So we have to be really flexible in addressing the business needs. But on top of that, we are also faced with constant new regulatory demands. New laws like the Digital Operational Resilience Act, DORA. If you're not familiar with this is something like an enhanced NIS2 for the insurance sector. Needs to be addressed in even shorter time frames. If you think back a few years, when the EU released the GDPR law or regulation, we had about 4 years to implement it, from announcement to it had to be effective. For DORA, we had 18 months. And the last details were announced in January this year. So the regulatory authorities expect companies to be much quicker in addressing their demands. And last but not least, new technologies like AI are developing quickly. And we need to keep up with it. If you think back a few years, if you wanted to write a program, some software developer needs to sit down and write all of it. Today, the basic structure of the program is generated, of course. Nobody writes the boring stuff anymore. So all these three demands are pressuring us to become more adaptable. And last but not least, and we heard this earlier, is cost efficiency. You have to have control over your budget, and you have to be able to actively manage it. It seems simple, but it is not an easy thing to do. You need to have cost transparency for your IT services. It is key for budgeting, and the budgets are getting tighter. We are faced with a huge inflation every year, and we as an insurance company, which is heavily invested in car insurances, are facing an even bigger inflation in this specialized department. And how can we address this? We need to be able to tier our services. If you're talking about a big company, you have different subsidiaries with different business models. So you need to be able to cater to these business models. You need to be able to provide cheap solutions for a more cost-sensitive business model and more quality solutions for another one. And last but not least, and that is a really important point, is the ease of use in licensing and pricing. We see an increasingly complex system of licensing. And a lot of companies, and we are no exception, are struggling to meet all these criteria, to make sure they're not over-licensing, they're not under-licensing. To get it just right is a huge effort. So ease of use in licensing and pricing becomes a selling point. So just to quickly recap, we are facing three challenges: complexity, adaptability, and cost efficiency. And these three challenges depend on each other. You can easily be more adaptable if you just spend money, or you can easily be more adaptable if you increase your complexity. But that is not what we try to do here. We need to take all three factors into consideration to provide a good solution, because if we do so, then we get a happy customer at the end. And now let's look a little bit how we do this technical. With our storage strategy, we are directly addressing these three challenges. We started in 2022 with our Ocean Store Pacific system. We have around 4 petabytes installed. And we use it as a storage system for our database backup. And it's really easy to consolidate all different databases we have onto this one backup system. So we're reducing complexity. And if we look a little bit further, we are even using it to tier our services. We can, using Huawei SmartSync, we can shift data to the cloud, to, for example, AWS S3 services or something like that. And that allows us to tier our services to save money. And this is something we just started, but Huawei and VHV are quite invested in it, so it's great to see that we are working together to even further this. And earlier this year, we decided to also buy a Dorado system, around 2 petabytes of capacity, and we are doing basically the same thing. We can now unify our storage. It's a unified storage system. We do not longer have to differentiate between block storage or file storage. For instance, if I shift a huge amount of file storage to whatever, let's call it Microsoft SharePoint, and I gain a lot of free capacity, I can now easily use this capacity to address my needs for block storage, or vice versa, of course. So it's a really, really nice feature. I really like this about this solution because it gives us adaptability. And in doing so, it allows us to even further reduce our complexity. In the future, we plan to even converge the storage system more on the Dorado by even migrating our archive system to this. And last but not least, ease of use is a point which is really important in this system, because as you can see, we bought it earlier this year and we plan to be fully migrated to the system by August this year. So that is not a long time frame for a whole migration of 2 storage systems. And we are really, really happy with it, that it is so easy to use. And it helps us to gain more speed, to become more adaptable, to be more cost efficient, and to reduce our complexity. So we as a VHV, experts, and you hopefully are insured by VHV experts, and we are backed up by our Huawei storage experts. Thanks a lot.
Thank you, Fabian. So we've just heard about 2 business innovations, and we're now going to go to the forefront of technology. As we all know, the purpose of training AI large models is for inference and solving problems in industry scenarios. So how can we improve the inference efficiency of large models? Academic and industry circles are in agreement that KV cache technology is key. Next, please welcome to the stage Fellow of ACM and IEEE, Dean of the Information Hub, and Director of the Big Data Institute at HKUST, Mr. Lei Chen, to give the speech, Optimizing Scalable LLM Inference, System-Level Strategies for Proactive KV Cache Management.
Thank you very much. First, thanks, Peter, for the invitation. I checked all the keynote speakers this morning. I'm only the academia, from the academician. Right? So, professor, now give me a talk. Now, wake up. The lecture is coming. So today, I'm talking about the optimized scalable LLM inference, system-level strategy for proactive KV cache management. And it's a very, very I try to make it very easy, okay, to understand. So this is the background. I don't know, like people talking about AI every day is like, like we are changing from Stone Ages to now what? Space age. And what is Stone Age? So in 1950 or 60s, and people starting using rules and to design expert system, right? So this is a bunch of rules and helped people expert system. It's like this in the Stone Age, we just use these tools directly. And in the recently, 1997, we have using the machine learning and a bunch of tools to design some algorithms, models to help people, and then to find patterns from data. In the late 20th centuries, deep learning come. We have lot of data, we have a lot of parameters, and we can do the image recognitions and even can beat human beings. So, and now in the recent 2 years, large model, large language model, everybody talking about it. Say like, if you don't talk about this, you don't know AI, right? Say like, talking about this, like they can do a large job, not only the image recognition, they can do multiple jobs together. So this is inferred to small model. What is small model compared with large model? Small model is working on a certain task, like specific task in the specific domain, right? For example, like I mentioned in 1950s, and people using these rules to design the expert system to help the chemistries, scientists to find what? Find the structures from the chemistry, right? Then in the 1997, Deep Blue, and this typical machine learning models, and used almost, 2,000 manually parameters. You cannot imagine manual parameters, but at that time, yes, okay? So they even beat the chess player, right? But that model is only can be used in the chess play, cannot be generalized even to other games. Let's say Go, okay? And in the 1997, in the 2012, and we have this deep learning model, the parameter size, data increased to what? 60 million parameters. Suddenly, machine beat human beings in recognize images. But all these models, no matter expert system, machine learning model, deep learning model, they all share the common problem. What? Working on the specific problem or single domain. Now, when we come to the big, large models, everybody using the pictures is that, this is big, large models use a lot of data and billions of parameters and a lot of GPUs. And then it's growing size, not only growing size, but it's growing in the performance. They beat small model in all the aspects, in the generalization, system ability, interpretability, and easy for use, right? So compare with small model. What is large model? They can work on all the domains, can have adaptability, have generalizations, multiple tasks, okay? So this is large model. So why large model becomes so popular, so advanced in recent years? Of course, hardware. Everybody knows that GPU and advanced every years, and like the computing speed. And other than that, data, mobile data, internet provide a lot of data, and then the algorithm plus everything together, LM, and in Concord, many applications recently, right? In chat, right? And in the coding, like nobody really study. Being a professor in the university, I was challenged. Why you still teach C++? Why you still teach Java? Come on, man. AI model can do better job than professors. They don't have bugs. You teach students how to find bugs. There are no bugs, right? So even document processing, like our secretary is really scared. The notes taking, minutes taking, speech, everything is ready using large models. So these things like make our life much easier. But what's the challenges? Professor like talk about challenges, right? Technical challenges. We are dealing with long context. Think about this dialogue model, right? I ask questions, and then the model return answer, and then ask further refined questions, and then on. So this context, long context, has been remembered and diagnosed and then understood by LM. And even say like LM, like just now, the previous keynote speaker even mentioned, like using the RAG to capture the recent data, updated data, in-time data, to let LM to catch the recent knowledges, not only the knowledge you dig from the old data, right? So if you think about it, using RAG, you capture data from the internet, whatever, so combined with the current sequence, the long sequence become larger and larger, and the LM have to handle it. And think about the other things, and another, I'll be talking about multimodal. I mean, not only text, you have image, video, audio. Think about the video, like put a set of, I mean, it's a very, very simple 10 minutes video clip, 1,440 frames, and then change it to the tokens, almost 10,000 tokens. Put it together, your LM have to handle it. So that's the problem. And then luckily we have the data scaling rule, test of time rules. As long as you have enough data, you have enough GPUs, your performance, very inference performance can be increased dramatically. Even you give more GPU to small models, they can beat the large models. This is giving another question, how the model can handle the long sequence, even you have enough GPUs. And here come to the motivations. Long context, right? And always been there. The reasoning, multimodal integration, multi-turn conversations, I asked several questions, and also retrieve argument generation, RAG, right? All these things require your LM model to handle long sequence. But how? How they being handled? Let's see a very simple example, auto-regression in the LM inference. This is the problem, right? Say like because of the transformer and the self-attention mechanism, every time you generate token, you have to get the previous token result, combine with it, and add the current token, and put it into the inference engines, your transformers, and then get out the next token. So every time you have to do this repeatedly. So this nature, right, make your computation, compute one token, become cojolic computation. But let's see the example here. Very simple, 4 query tokens. And you compute the K, and you multiply K with your query tokens, you generate the K values, you output 1 tokens. Okay, so you can see here, you multiply the K 1 to 4 multiple times. Does it necessary? Yes, not necessary. Come on, you can use your storage, store something. The previous loss, K1, 2, 3, can be stored. Then when you compute the token 4, you just use the previous result. So now what we are using? We are using the memory, we are using the storage to trade off what? Computation, right? We don't compute, we store them. But no lunch is free, right? So you think about it, you use more storage, you think memory is free, nobody really charge you memory, I don't use computation, I don't use computer now. I don't use computation, I use memory, I store there, I just retrieve it. Come on, look at this. The long context, the KV cache, this mechanism, we just store the intermediate result called the KV cache. This mechanism require, I mean, see, with the length of context growth and also the batch size, the hidden size, it's dramatically increased. The memory cost increase. And just very simple example, you just use a very simple OPT30B, and also the sequence length is 8,192 and 16 requests. The memory request is over 200 gigabytes, right? And the normal A100 GPU, only 80 gig. So what's the problem? You cannot fulfill the demand of these memory requirements. So that means if you cannot do it better, you have out-of-memory failure, you have high response latency, your customer will be waiting for a long time because they have to wait. The memory is coming, and then your low generated throughput. So this is really the problem if you're using KV cache. Now how we do it? In academia, we are really go forward, right? And then say like, oh, we can do it. We can do better. And even with the current storage structure, what do we do? There are many factors, right? Memory efficiency, accessor efficiency, container migrations. And then in order to measure KV cache, what do we saw? The first, how to store. The second, where to store. The last, which and when to store. Very simple question. We have to solve it. Let's see the first one, how to store. Okay? And then previously, when you have a KV cache requirement, one request, so you just get the longest sequence and put there. It's easy, right? Say like, oh, I found that your multiple tens, you need 128 token size. I just allocated this memory to you. It's very easy. And for the computation and for storage, for the access, easy solution, naive solution here. I always allocate the maximum token length for your request. But what's the problem? You cannot use it. According to the data, only 20% of the allocated memory being used. Then 80% unused, you waste the memory. So what's the solution? Very simple. You cut your allocated memories into buckets, right? Instead of in the whole memories, I cut it, the KV cache, into buckets. For example, the buckets can be 4 tokens. So here is very simple examples. I mean, in order to let people understand, right? We use example, very simple. Request A need 4 tokens. Then I have buckets of 4 tokens. I put it in the bucket 2 or bucket 1, right? Bucket 1. Then I have the next request, 7 tokens. In 7 tokens, I put it where? In the bucket 0 and bucket 2. What I waste? I only waste 1 token in the bucket 2. Very, very simple solution. It works. And of course, you will say, why is 4 buckets? Why not 8 buckets? Why not 12 buckets? Yes, exactly. This is research. And we are working on it. We really think, oh, what is the optimization solutions? And we design the problem, we solve it, we solve the mathematics formulations. But this is just simple example. They are example to solve this problem. We can formulate it as an optimization problem. We are also dealing with the problem previously, like you use continuous storage, right? You put them into 1 chunk storage, you can easily extract them. Now, for the second request, request B, you put into 2 buckets. So that means you have to retrieve the first and then find another one. They are separated in 2 buckets. The retrieval time increase. Yes, that's the trade-off. Why the bucket size and then the retrieval time? Okay, first, assume we solve it. Second, storage management, where to store? This is a very interesting question. As we know what? We don't have enough memory, HBM, right? Say like a GPU have limited memories. How much memory we have? This is the say like motivation is instead of computation, we store them. And instead of recompute, we just use the GPU memories to store the previous result. Then with the increased number of requests, your memory will be run out. Then you have to wait, right? Say like this is a problem. You don't have enough memory. So come on, we have other than HBM, what we have? We have host memory, we have host disk, 3 tiers. Can we reuse it? Yes, why not? Why you just ask your request, wait for the HBM? You can reuse the host memory, you can reuse the host disk. So how you reuse? Very simple, give very simple examples. Here, for the request A, it comes, oh, my HBM is empty, just put it in, right? Very good. So request B come, oh, my HBM is full, sorry guy, you have to wait. Okay, don't wait. Put it in the host memory. But you say, oh, then from the host memory to the GPU, HBM, it takes what? Communication cost. Lay, you are cheating. You see like you put there, but still, you have the memory, and then you have to store and transfer data to HBM. The communication cost really slow. Wait. You know, transformer have layer by layer. We don't need to transfer the whole trunk. We can cut it to layers. So when we transfer 1 layer of data, at the same time, we do the computation of the next layer. So we can hide, using this pipeline to hide the communication cost inside of computation. Same thing for the disk. We can do this hide the communication cost inside of a computation. In these cases, for request A, B, C, we can store them, pre-compute them. Whenever they use it, we can load them to the HBM. Okay? So that's a simple solution. We use 3 tiers of the storage, not only use 1 tier. Now try to reduce the delay. Last one is very interesting one. I like this idea because it's an idea from our group. Okay? So this is called how you store the data and when and which. Again, what's the expectation when you use LM and you want the response fast? So there's a metric called the time. There's a metric here called time to the first token. So when you submit your request, The first token come back. That's the time, elapsed time, right? And then you are waiting. So within 1 second, within milliseconds, you want the result ASAP. You don't want to be talking about, oh, based on this analyze, based on that analyze, give you results. I want the results. So the time the first token come back. TBT is the time between token. So actually, with the number of requests increase, the time actually, especially, I mean, we have limited memories, and then the more and more requests comes, you can see the time to the first token when the request rate increase and the satisfaction rate, I mean, people are satisfied with this time drop. Clearly, because more requests and more requests to put into a KV cache, and your KV cache is limited, right? You don't have enough. Then you have to wait. Then the people are not happy. And here is the issue. So memory-intensive KV cache poses a hard limit on the attainable batch size, right? So batch size is limited. So you accrue the delay with high request rate, right? Say like a lot of requests have to queue there waiting. So what's the solution? Say like this is where and when, right? Solution, say like how you start this request. The first solution is first come, first serve, right? When the request come, I just put it into the KV cache. This is bad, right? Say like, what if this request really, really long, and these guys want to ask a lot of questions and find the details, even use the video, and the other requests have to wait. So this is scenarios. When you do it first come, first serve, you can see, you can see the figure, the random. Random is like I don't do the first comes, first serve. Anytime I do the random draws and pick up the requests and put in and give them the KV cache, okay? And it's interesting. So random beat the first come, first serve. Think about this is very, very, understandable. Why? Because as I just mentioned, the first one, maybe the one is the worst one, like it requests a lot of resources, a lot of KV cache. So the others been drained, delayed, and this delay is cascading to the following request. But the user random maybe break this, right? So you can see from the figures, our observation is that like maybe random is good, but this is not the solution. If you see that scientist and come to the stage and say my solution is random, people say I can do it. The random draw, everybody can do it. No, we are doing better. You see, think about it. People think about using storage trading for computations. And in this case, if we don't have enough storage, what can we do? Can we trade computation for storage? So reverse thinking. And people always think we have enough storage, but no. When the request intensive comes, right, you don't have enough storage. So what we do is the hybrid caching. Instead of cache KV, everything KV pairs, what we cache is cache the initial node or the hidden nodes of this KV. Instead of compute and store the key and V, we just go further, go front and find the points like we can compute KV. So we store that value. When instead of store 2 copies, we store 1 copy. When it is necessary to get KV value, we just compute it. So here you say, oh, we cheat, right? We use computation to save storage by half. Let's see the example here. Very simple example. We have the first iteration. We have request A of length 5. KV cache use 10 elements. You can see it's stored there, 10 elements. The second request need the length 3, and 3 multiplied by 2 because KV and 2, and you can store 6. Now for the iteration 2, the request C come. You can say, oh, I need 8, right? Every iteration you have to append the previous result. So requests increase by 1, from 5 to 6, from 3 to 4, and now you have this many. And then here you see like the request is 4 and the double 12, 12 plus 8, 20, and here need 16. You don't have enough. So what to do? You ask request C to wait. Wait, no, we don't do that. What we do is that instead of using the KV store there, we compute result, put half of the K, half of the B, half of the A, or half B there. So we save some spaces so request C can be put into KV cache. Okay? So that's the trick. But of course, you will say, oh, it seems very simple, but how? When you do the computation to trade off storage, that's the tricks. Okay, so let's do summarization. For the KV cache management, definitely it will help large model to do the inference from storage, how to store, from where to store, and lastly, which and when to store. So this is the topics when people discuss in the academia. But we are not only working on the academia. We are talking about today. Peter asked me to talk about storage, okay? So starting from the bottom, we are talking about the revolution AI native storage. We are building these storage structures just for large models. See, your storage structure have a lot of HBM. Of course, we are happy. But this is AI native. But think about the go up levels. Think about these defined dynamic cost functions. We have hot cache, we have cold data, and how we can combine them together. We have a cost function to define the structures, like when we have hot, when we have cold, we can combine them together. Go up levels. What else? You are building the ecosystem, not only the storage. You are building the computing system, right? And network, right? Think about data being transferred through network. So you're building an infrastructure to unify storage, computer networks, and co-design together. So this is the way you should go. Finally, what else? Once your data being stored there, you know the data value, you do the data governance. So this is the goal, right? We are the boss to say which data is useful, which data is not useful, which data we store. Finally, it's time for us to think, to design the next generation storage structure. It's not just for today's LM or KV cache. It's for us to build the foundation model for AI to conquer the world in the next decades. Thank you very much.
Thank you, Lei, for giving such an informative presentation on AI inference. Now, what first comes to mind when you think of Formula One? You might think of extreme speeds and intense competition that keeps pushing the limits of performance. This is also the brand spirit of Huawei Ocean Store. It strives for excellence and pushing the limits. But what's not so widely known is that behind the most successful Formula One teams is the power of data. So at the end of this morning's keynote, we have a special speech in store for you. Neil Martin is a renowned Formula One data scientist and the former head of strategy at Ferrari, Red Bull Racing, and McLaren. He'll be sharing behind-the-scenes insights and experiences from 3 decades spent pioneering data analytics, modeling, and technology as key tools to transforming performance, reliability, and safety of world motorsport. Welcome, Neil.
Thank you very much for that kind introduction. Now, before we do a deep dive into the world of Formula One, I'd like to firstly warm you all up with a few fun facts. So, Formula One itself has been around for 76 years. In that time, we've undertaken over 1,100 races all around the globe. In terms of audience figures, we can reach 300 to 400 million viewers live at each and every event. Now that's matched only by the Summer Olympics and the Football World Cup. Each of those events happen once every 4 years. We put on a show once every 2 weeks for 9 months of the year, every single year. So we are a huge sporting and marketing juggernaut. On to the teams then. There are only 10 teams, all design, build, manufacture, and race just 2 cars. A car is made up of around 40,000 bespoke components, and we have budgets of around 140 million US per year. There are about 750 people per team, and the 2 most visible are, in fact, the drivers. Now, for those of you who watch Formula One or don't like Formula One, you will not understand what incredible athletes these drivers are, because the TV just does not do it justice. But actually, the forces on the body define how much strength is required. So they are controlling an unstable car on the edge of performance for an hour and a half in temperatures of 50 degrees C, and they'll lose about 2.5 kilos in sweat during that duration. So they are incredible athletes. So that's my Formula One in a nutshell for the uninitiated. Let's now get on with our data journey. So our data journey began in the late 80s. And we used to have this little black box that used to sit on the bottom of the car, and we used to record the basic channels. Speed of the car, what gear you were in, when you were braking, how heavy you were braking, and a few forces on the suspension. And what did we use it for? Primarily performance. We used it to set up the car so it would ride over the curbs really nicely. And on top of that, we used it to get the maximum out of our drivers. So because we had this data, we would put one driver's data on top of the other driver's data and say something like, David, Mika is braking 5 meters later, he's in a higher gear, and he's gaining 0.3 of a second. Maybe you'd like to have a go at that. So in egging on the drivers, we got a performance advantage as well. But twinned with this fun, Formula One had a dark side. Between 1950 and 1994, we suffered 47 fatalities. And it came to a head in 1994, 1st of May. In 3 separate incidents, we had 3 drivers sidelined, 2 of which were actually fatalities, one being the late, great Ayrton Senna. And it brought Formula One to a crisis point because this was no longer acceptable. It was never acceptable, but it was now a televised worldwide event. So all of the teams got together and they said, we've got these little black box loggers. Can we repurpose the data from performance and turn it into safety? Because if we can understand the anatomy of an accident, then we can predict the likelier failure modes and then address them. And that's exactly what we did. And between 1994 and present day, a little over 30 years, we have only suffered 1 further driver fatality. So what an incredible change around by just doing predictive analytics. Now, a lot to do with safety goes on underneath the surface of the car, but every now and then a device is visible. And the one I want to talk about is the halo. It's the hoop there above the driver's head. Now, this is really fascinating because the establishment didn't want it. The drivers didn't want it. They all said, oh, that will ruin the DNA of the sport because you'll hide the driver even more. But the data and the predictive nature of it was saying that actually we will have more fatalities if we don't put something in place. And the data held sway. And in 2018, the halo came into play. Within that year alone, it saved Charles Leclerc's life. And then a couple of years later, it saved Roman Grosjean's life. So it was a really important thing how data and predictions drove the environment. Now, the naysayers said, when you make things safe, you'll actually make things slow and you'll make things boring, reliable, boring, slow. But we found the antithesis was true. And this is best demonstrated by 23 ordinary people doing one extraordinary task. Right, for the keen-eyed amongst you, you'll have counted the 36 operations that went on in 2 seconds there. No? Okay. For those in just joining a pit stop, let me take you through the process of how we achieve that repeatable excellence. The first thing is you all saw a pit stop, but we see data and a mathematical equation, and we're trying to minimize the overall time whilst both maximizing repeatability and safety. So we did a time and motion study to calculate the cost of every movement. And the first thing we noticed was that actually the driver had to park perfectly in the box. If the driver missed by just 10 centimeters, it would increase the overall pit stop time by 25%. So that's a significant increase. And I think we can agree Fernando has parked perfectly in the box there. Beyond that, you'll have noticed that the car was jacked at the front and rear, which means it can wobble on its axes. And analysis showed in 1 in 4 times the wheel wasn't going on smoothly. So with that in mind, what happened was we needed a stabilizing team. And that's the 2 people either side of the driver. Now, what always makes me smile in the world of high-tech Formula One, the optimal solution is 2 people just pressing down on a car. But it does show Occam's razor is alive and well in Formula One. Now, we always also look at backup solutions, mitigation strategies, much like in the data and IT industry. So we've got 3 guys at the back in case the car stalls or we have a rear jack failure. And we also have spare wheel guns in case we have primary failures. So we're looking the whole time at everything as a system. Now, the thing is, I've shown in the area of safety and also in the area of performance how if we embrace data and use predictive analytics, we can gain an advantage. But I haven't told you yet how we actually collect the data. So while the car is on track, it's sending 100 megabytes of data constantly back to the garage. From there, within 60 milliseconds, it's bouncing back up to the factory HQ, where there are another 40 or 50 engineers looking at what's going on. So we've got extra bandwidth. Now, by embracing technology, that's also helped our green credentials, because those 40 and 50 people have exactly the same experience as if they were at trackside. However, we've done no travel, no flights, no hotels. So actually, it's not a restriction, it's an enhancement. But for those of you who are lucky enough to actually go to trackside, the one question they always ask me is, Neil, why all the screens? Why all the computers? Well, the answer is they're looking at the safety of the car or the performance of the car. Now, if you imagine we've got 1,000 virtual sensors that all generate data at about 1,000 hertz, so you've got 1 million data points a second going on. So it's not possible for us mere humans to actually analyze that. So as you may expect, we have applications and algorithms that are monitoring those channels for us. So if you think of something like a gear change, that will have a signature through all of the sensors as we move forward. Now that gear change itself, we have the application going, good gear change, good gear change, good gear change. But that's not the clever bit at all. The clever bit is it's actually consuming that data and looking 2, 5, and 10 laps ahead to predict whether we're likely to have a problem in the future. So for the petrol heads amongst you, for those of you who watch, you might have heard a call to the driver to say, go to yellow G4, and that's telling the driver to go to a different setting to prevent a problem that has not yet developed. So that is where the power of our predictions come in. We've moved into the proactive technology. But I've mentioned the simulator there. It's so powerful, it deserves a slide all to itself. So the first thing I always say is it's not a PlayStation Plus. It is, in fact, the digital twin of the real car. And again, when restrictions are put upon us, such as banning testing, we actually find a way to both comply and outperform. So this simulator then, in the bad old days before the simulator, we would draw components, make components, take 120 people to the middle of Europe where we would test those components. And at the end of it, they'll go, yeah, not really sure. So think of how much energy and momentum was in that compared to the simulator, where we actually just create a mathematical model. We have some coders who code that up. We get the race drivers into the simulator where they test these virtual components and characteristics. Then at the final stage, do we only build real components? So we've turned the process on its head and gained huge acceleration in development as a result. So extra rules and compliance just equals more innovative ways to get around them. And what I'd like to now do is take you to trackside to show you two such things of predictive analytics and AI. Now, at the start of any given season, what happens sometimes is all of the rules change. And in Australia in 2003, they did massively. What happened is, first of all, you had to qualify on the fuel that you took into the race, and there was refueling. And also, on top of that, what we had was the fact that with the rookies there, they could actually take fuel out of their car and qualify higher up, and then the faster cars would be more at the back. So you've got a lot of parameters going on. You only had one shot at qualifying back then. So all of these mixtures went into our simulations, and a month before the race, I went into our team principal and I said, hey, guess what? We've run the simulations, and if we don't qualify on the front two rows, we should actually pit on lap one of the race. Now, that's not received wisdom, and it was only doing these simulations did it actually present it. Now, the team principal was like accepting of it, but he was like, not with our cars, right? And I'm like, no, if we do a two-stop fuel load and don't qualify on the front, we are doing that. So we get to Melbourne, and we qualify 11th and 15th. So that actually gave the opportunity to try out the trusted AI models. So what I did was, on the formation lap to the grid, I pitted Kimi Räikkönen from 15th position. And then all of the cars barreled down to the turn one, and there was absolutely no safety car, which is what the models relied on. So then they come on the radio, Neil, what do you want to do with David, our other driver? And I said, well, the simulations are still saying there's going to be a safety car because the rookies are at the front. So we pitted David. Now, I don't know how many of you have made decisions in front of 300 or 400 million people live, but I was close to closing my laptop as the cars all went by again with no safety car. But where we were is we pitted both cars by lap 3 of the race. Everyone else was in the distance. And then the magic happened. A safety car came out, and all the cars concertinaed. Now, what happened, which was interesting, is the fact that because our competitors had not embraced the models and predicted the future, they operated to the race rules as if it was last year, which allowed us to close up. Now, everyone else had 2 more pit stops to make. So as they pitted, they went behind us and even further behind us. So now we're leading the race. I mean, it looks like we're going to win. Now, we would have got a 1-2, but what happened, I seem to remember, is Kimi Räikkönen got a speeding penalty in the pit lane by 1.1 kilometers an hour. Now, not that it scarred me, but 20 years later, I remember that figure. But what it shows is actually anti-intuitive, not received wisdom solutions can be found by adopting predictive analytics. And if we take that further, what does the future look like? Well, I'd now like to introduce, for those of you who remember 2021, the final race, there was a questionable decision by the race director. And what happened was it arguably altered the outcome. Now, race directors are under a lot of pressure, and I mean heavy pressure, and they're under the guise of the audience. So there's a lot going on for them. So what we did is we invented Apex by Pacetech, and it's the AI race director. Instead of getting overwhelmed by all of the inputs that a human would, it's consuming the rules. Not only is it consuming the rules, it's actually consuming all of the data and all of the TV feeds. And what it's doing is omnipresent processing that. And when it sees, like, for example, on TV, a yellow flag, it's able to get the case together, it sees it, it references the rule, it shows its reasoning down the right-hand side, and what it does is it takes the pain out of it, it gets that evidence case, it puts it forward to a human to actually make the final decision. And in this case, it actually was a penalty. So it takes the emotion out of things and creates a crystal clear case by removing the human from the data collection, but not the decision. So I think what we're seeing here today is that when I started in Formula One, we were a prototype engineering company. But actually now, we have more in common with data and technology companies, because we are all in analytics races today, and data plus technology will give us a competitive advantage in any business. Ladies and gentlemen, thank you very much.
Thank you, Neil, for your truly riveting speech. Data awakening, AI rising. We've been able to take away plenty of ideas here, which will allow us to move calmly and confidently into the AI era. Well, that's the end of the morning's keynotes. This afternoon's keynotes will begin at 1:30 back here, where we'll dig deeper into more aspects of the data world. And now lunch has been prepared just in the studio next door. Please enjoy, and we'll see you back here at 1:30.